Good day. This is Mr. Lloyd U. Andres, a senior high school math teacher. I'll be presenting a video lesson entitled Definition and Equation of a Circle. So to start with, let us first illustrate what a circle is. Please refer to this figure 1.7. If you can see, in this figure, we have points C with coordinates 3, 1, A with coordinates -2, 1, B with coordinates 6, 5, and P with unknown coordinates. In this figure, if you try to determine the distance from A to C, we can see that A is 5 units away from this point C. By counting the units away from these 2 points, we have 1, 2, 3, 4, and 5. So therefore, A to C is 5 units. While if we are to solve for the distance from B to C, since these 2 points are not aligned vertically or horizontally, unlike A to C is horizontally aligned, so we can directly count the number of units to determine the distance. But B to C, we need the distance formula. So recall the distance formula. To determine the distance from B to C, we will use the formula square root of the quantity x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. Based from this figure, x sub 1 will be this 1, 3, and y sub 1 will be 1. And for our x sub 2, that is the x coordinate of B, and y sub 2 will be the y coordinates of B. So substituting the value, the distance will become square root of the quantity of 6 minus 3, because our x sub 2 is 6 and our x sub 1 is 3, plus the quantity of 5 minus 1, because our y sub 2 is 5 and our y sub 1 is 1. So simplifying, 6 minus 3 becomes 3, and 5 minus 1 becomes 4. And then 3 squared is 9 and 4 squared is 16. If we add 9 and 16, that's 25. Square root of that is 5. Therefore, we can conclude that the distance from B to C is also 5. So meaning, from A to C is 5 units, from B to C is also 5 units. We also have this point on the circle denoted by P. And since it is on the circle, we can directly say that the distance from P to C is also 5. And all the points actually on this circle, their distances from this point C are all 5. Because if we let C be a given point, this one, with coordinate H and K, the set of all points P having the same distance from C is called a circle. The point C is called the center of the circle, and the common distance is its radius. So this is the formal definition of our topic, which is circle. When you say circle, it is the set of all points having the same distance from a fixed point. So if you are asked to illustrate the circle, this is how to illustrate a circle. You should give a point, and then you should draw such that all the points around that center, the distances are all the same. So for the standard form of equation of the circle, we will be using the definition as well as the illustration of the circle. So since the distance from P to C is our radius, and the length of this one is just the distance from P to C. So we can use that statement as a starting point to derive the standard form of equation of the circle. So we can say that PC is equivalent to R. And then using the distance formula to solve for the distance from P to C, it is just equivalent to the square root of the quantity x sub P minus x sub C squared plus y sub P minus y sub C squared, which is equivalent to R, because this is equivalent to R. So we only use the distance formula. We substituted the distance formula. Then continuing from this illustration, our x sub C, or the x coordinate of our C, is h. So we can substitute it here. And the x coordinate of the point P is simply x. So substitute it here. And then same goes with y. The y coordinate of our point P is y. So that's why this becomes y. While the y coordinate of our C is k. That's why this becomes k. Square both sides. So this becomes the quantity of x minus h squared plus y minus k squared is equivalent to r squared. So this is now our final standard form of equation of the circle. Let's discuss some example. In each item, give the standard equation of the circle satisfying the given condition. Say for example, you have a circle at center at the origin, whose radius is equivalent to 4. So to determine the standard equation of this circle, we will use the standard form of the equation of the circle, which is previously derived as the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. And then since our given situation states that the center is at the origin, meaning its center's coordinate is 0, 0. Again, the coordinates of the center is denoted by h and k. So therefore, the value of our h is 0, while the value of our k is 0. And we are given that the radius is 4. So this will now represent our variable r. So using these given values, we can now substitute in this equation. So substituting h with 0, and substituting k with 0, and substituting r with 4. So simplifying, x minus 0 is x squared, and y minus 0 squared is just y squared, and 4 squared is 16. So therefore, the standard equation of the circle whose center is at the origin with radius 4 is x squared plus y squared equals 16. So another example. What if we have a circle whose center is at negative 4, 3 with radius square root of 7? So based from the given, we can say that the value of our h is negative 4 because h is the x coordinate of our center, while k is the y coordinate of our center. So h is negative 4 while k is 3. And our radius is square root of 7, so this is our r. And since we already have h and k and r, we can now use the standard form of equation of a circle, which is the quantity of x squared, x minus h squared, plus the quantity of y minus k squared is equivalent to r squared. Substituting the values, we have h becomes negative 4 and y becomes 3 while r becomes square root of 7. Simplifying x minus negative 4 in subtracting, we need to change the sign of the subtrahend, then change the operation to addition. So that will become x plus 4, the quantity of x plus 4 squared. Then y minus 3, you just have to copy that one, and square root of 7 squared becomes 7 because square root then squared can be r inverse operation. So that will be simplified as 7. So this is now our final answer. This is the standard form of equation of a circle whose center is at negative 4, 3, and radius at square root of 7. So for the third example, we are asked to give the standard equation of the circle in figure 1.7. In figure 1.7, we are given a graph with given center whose coordinates are 3 and 1 and given radius of 5. So therefore, our h is 3, our k is 1, and our r is 5. So we can now use the standard equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared, to solve the standard equation of this circle in figure 1.7. We just need to substitute the values of h. So h becomes 3 based from here, and k becomes 1 based from here. And then our r becomes 5. Again, based from the given graph. And simplifying this one, the final answer will be x minus 3 squared plus the quantity of y minus 1 squared is equivalent to 25 because 5 squared is 25. So this is the standard form of equation of the circle in figure 1.7. So that's example 3. Let's proceed to example 4. This time we are given a circle in figure 1.9. In the previous example, we are given the center and the radius in a given graph, but in number 4, we are only given a graph without the coordinates of the center and the length of the radius. So we need to determine first the coordinate of the center. So that is example, that is circle A. So this is the circle, the center, then its coordinate is negative 2 and negative 1. So based from this, therefore we can say that our h is negative 2 and our k is negative 1. While our radius, to determine the radius, you simply need to count the number of units from the center to the circle. So it can be, you can go upward, downward, or sidewards. So let's try to use, let's try to go upward. So from here, we count 1, 2, 3, 4. We have 4 units from the center to the circle. So therefore, our radius is equivalent to 4. Since we already have our h, k, and r, we can now use the standard form of equation of the circle. And this is the standard form, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. We just need to substitute h with negative 2 because our h here is negative 2 and k with negative 1 because k is negative 1. The y coordinate of our center is negative 1. Then Next one is we simplify. X minus negative 2 is just x plus 2, and y minus negative 1 is just y plus 1, and 4 squared is 16. So therefore, our final answer is this one. So we can now conclude that the standard equation of the circle in figure 9, circle A in figure 9 is the equation is the quantity of x plus 2 squared plus the quantity of y plus 1 squared equals to 16. So that's the standard equation of circle A in figure 1.9. Next is circle B. Similar with circle A, we need to determine with the center, coordinate of the center. And the center of the circle is, we just have to count 1, 2, 3. So the x coordinates is 3, y coordinate 1, 2, 3. 1 and 2. So 2. Positive 3 and positive 2. So therefore, our h is positive 3, our k is positive 2. And then, next is we need to determine the radius. So we count from center, we go upward, downward, sidewards. So this time we try to go sidewards. So from here to the right, we have 1, 2, 3. So we have 3 units from the center to the circle. So therefore, our radius is 3. So since we have already h, k, and r, we can now use the standard equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. Substituting the values, h from here is 3, k from here is 2, while our r is 3. So simplifying 3 squared becomes 9. So therefore, the standard equation of circle B in figure 1.9 is the quantity of x minus 3 squared plus the quantity of y minus 2 squared equals to 9. So that's example 5. Let's discuss another example. The given circle has a center of 5 and negative 6. And another condition that it is tangent to y axis. So from here, we can now directly determine that the value of h is 5 and the value of k is negative 6. But there is no data that tells you what is the length of our radius. For us to be able to determine the radius, it is advisable to sketch the given circle. If we try to sketch the given circle, the circle should look like this. Your center is at 5, negative 6. So this is 5 here, and negative 6 here. So therefore, the circle is here. So from this figure, we try to determine the radius. Again, in determining the radius given a graph, you need to count the number of units from the center to the circle. You can go upward, downward, to the right, or to the left. So it is up to you. So let's try this time, since the given is tangent to y-axis, meaning we are sure that we have a point here, a point of tangency here. So we try to determine the distance of this point of tangency to this circle. So counting the number of units, we start with 1, 2, 3, 4, and 5. So since C is 5 units away from this point of tangency, we can say that our radius is 5. So since we already have h, k, and r, we can now solve using the standard form of equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. We just need to substitute h with 5 because the x coordinate of the center is 5. and substitute k with -6 because the y-coordinate of the center is -6. And radius, we just need to substitute it with 5 because based from the graph, our radius is 5. Then next is we have to simplify. Since y minus -6, we need to change this sign and change the operation, so that becomes y plus 6, and 5 squared becomes 25. So therefore, the standard form of the equation of the circle whose center is 5, -6, and tangent to y equals to x is the quantity of x minus 5 squared plus the quantity of y minus 6 squared equals to 25. So this is the standard form. So that's example 6. We proceed to example 7. This one, same with example 6. Its center is at 5, 6. So therefore, this is again our h, and this is again our k. But this time, it is now tangent to the y-axis. The previous example is tangent to y-axis. This time, it is tangent to the x-axis. So again, we have hk, but we don't have r. So we need, or it is advisable to sketch the graph. Sketching the graph will look like this. So our center is at 5 and -6. So this is -6. This one is -6. So therefore 5 and -6. But it is tangent to the x-axis. This blue line is our x-axis. So it is tangent to x-axis. Therefore, we have a point of tangency here. And this will help us to determine our radius because the distance from the point of tangency to the center will be equal to our radius. We just have to count the number of units. So counting, we have 1, 2, 3, 4, 5, and 6. So therefore, our radius is equivalent to 6 units. So since we already have radius, which is 6, and values of h and k, which is 5 and -6, we can now use the standard equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. Next step is just substitute h with 5 because it is the x coordinate of our center. And again, k with -6 because it is the y coordinate of our circle. Our center. And lastly, our radius is 6. So again, simplifying this one, this becomes +6 and the operation becomes addition. So therefore, the standard equation of a circle whose center is at 5, -6 and tangent to the x-axis is this one. The quantity of x minus 5 squared plus the quantity of y plus 6 squared equals to 36. So that's example 7. And lastly, this is example 8. Example 8 involves a circle with diameter having an endpoints A with coordinates -1, 4, and B with coordinates 4, 2. In this problem, we don't have the coordinates of the center, which is HK, as well as the length of the radius. So it is advisable to sketch the given circle. In sketching the given circle, we will use the endpoints A. So we will plot this point, whose coordinates is -1. This one is -1. and y coordinate is 4, so therefore the intersection of that will be point A. While the other point B has coordinates 4, x coordinate 4, and y coordinate 2. So the intersection is the point B. So after plotting the endpoints of the diameter, so if we connect point A and B, will serve as the diameter of the circle. And the point in between A and B is actually the center of the circle. So to determine the coordinate of this center, we need the formula for the midpoint. So let's recall the formula on how to solve the midpoint. So for the midpoint of AB will also equal to the coordinate of your center. And the formula for that is the x coordinate of B plus the x coordinate of A divided by 2 will be the x coordinate of your center. And for the y coordinate, you just have to add the y coordinate of B and the y coordinate of A and divide it by 2. The answer will be the y coordinate of your center. So substituting the values, our x coordinate of B is 4 and our x coordinate of A is -1. While the y coordinate of B is 2 and the y coordinate of A is 4. So simplifying 4 plus -1, that becomes 3. And 2 plus 4 becomes 6. And dividing 3 by 2, same with 3 halves. And dividing 6 by 2 becomes 3. So therefore, our coordinates of the center is 3 halves and 3. So we now have the values of our h and k. H is the x coordinate of our center, while k is the y coordinate of our center. So the next problem is the length of our radius. To solve or to determine the length of our radius, we simply solve the distance from the center to any point. It can be point B or to point A. But since these points are not vertically or horizontally aligned, we cannot use the simple counting of number of units, but instead we need to use the distance formula. So to solve for the radius, we can choose to solve for the distance from C to B. So solving for the distance from C to B, it is equivalent to the square root of the quantity x coordinate of B minus the x coordinate of C squared plus the quantity y coordinate of B minus the y coordinate of C squared. Then, substituting, the x coordinate of B is 4 and the x coordinate of C is 3 halves. Next, we substitute the y coordinates of B. Y coordinate of B is 2. That's why this becomes 2. And then the y coordinate of C. Y coordinate of C is 3. That's why this is 3. So we try to simplify the values inside the parentheses. So 4 minus 3 halves is actually 5 halves. And 2 minus -3 is -1. Squaring 5 halves becomes 25 over 4. Squaring -1 becomes 1. Then simplifying 25 over 4 plus 1 becomes square root of 29 over 4. So we now have the value for our radius as well as the value of our h and k based on the coordinates of our center. So from that, we can now use the standard equation of the circle, which is the quantity of x minus h squared plus the quantity of y minus k squared equals to r squared. The next thing to do is to substitute the values of h. H is 3 halves because x coordinate of our center is 3 halves. K is 3 because the y coordinate of our center is 3. And our radius is square root of 29 over 4. Because we have determined using the distance formula that the radius is square root of 29 over 4. Then, simplifying this one, the square root of 29 over 4 squared is just 29 over 4. So therefore, our final answer will be the quantity of x minus 3 halves squared plus the quantity of y minus 3 squared equals 29 over 4. This will be the standard equation of the circle with endpoints of the diameter given in this problem. So these are some of examples on how to solve equation in standard form of a circle. So actually that's all for the definition and equation of a circle. Hopefully this discussion can help you in answering the next activity. Thank you and adios.